There you go. So yesterday we said that the format of writing scientific notation will be n times 10 to the power of b. That was what we copied yesterday. The n is called the mantissa, and the times 10 is fixed there, and the b is our exponent. The exponent can either be a positive exponent if your given is more than 1, and if the given is less than 1, then your exponent should have a negative sign. Now, this is the format. What is it that we need to remember for the writing of our n? On the board, you will see whatever it is that you need to remember with n. And let me read it to you. The n value has to have one non-zero number before the decimal point. Again, there should be one non-zero number, and it should be that non-zero number is before the decimal point. Then I will discuss this, how it looks like, what that means, Miss Narca. Before the decimal point, one non-zero number. So let me go back to number 1 as an example. Let me erase this first. Number 1, you have 35,500. This is a whole number. The first thing you need to ask yourself is, how many significant figures do you have in this number here? Let's count. You have 3, 5, and 5. Do you count the 2 zeros to be significant in this case? No, because zeros to the right are not counted if there is no decimal point. This is a comma. That's not a decimal point. So in this case, you only have 3 significant figures, correct? So that means in the final answer, you should be sticking to this number of significant figures. If it's 3 in the given, final answer should be 3 as well, unless otherwise stated. But in this case, it's not stated. So we stick with the number of significant figures in the given. So the next thing we need to do, after identifying our significant figures, which I encircled, we have to encircle the 3 significant figures to make it easy later on. The next step is we will place the dots or the decimal point at the correct place. If you look at your given, this is a very huge whole number. There's no decimal point. So it is assumed that if there is a decimal point in this number, it's all the way to the end because it's a whole number. So the starting point is here. And we need to transfer this decimal point to the place where you only have the first non-zero number, which is 3, before the decimal point. Again, let me repeat. You should only have one non-zero number before the decimal point. So that means I have to transfer my decimal point in this spot between 3 and 5. Because the rule says that I have to have only one non-zero number before the decimal point. And so after identifying where's the final destination of my decimal point, we will now count how many numbers do we skip from the starting dot all the way to the final dot. Let's count. So this is how you will count. 1, 2, 3, and 4. So we skip 1, 2, 3, 4 numbers for us to arrive at that destination. You put the 4 there as a note that you counted 4 times. This value of 4 becomes the value of your exponent. So basically, the exponent of a scientific notation coincides with the number of times you skip to be able to take your dot to the final place. And after identifying how many times you skip, ask yourself, should this exponent be positive or negative? Should this be positive or negative? Look at your given. Is my given 35,500 a number greater than 1 or less than 1? It's greater than 1. So should it be positive or negative? Positive. So just have it as 4. And now we're ready to be able to write our final scientific notation. We can readily write them. Just write first whatever is inside the circle. Inside the circle, you see, let me write that down, 3.55. 3.55. That's what you see inside the circle. The dot has to be copied now because that's the final place. And by writing the 3.55, that becomes our n value. With 3 significant figures. 1, 2, and 3. And then now, you can write times 10. And what will be our exponent? Just copy the one you wrote there. We move 4 times and it should be positive. So I put positive 4. And that is the final answer to number 1, expressed in scientific notation. Let me repeat, that's 3.55 times 10 to the power of positive 4. That's for number 1. Any questions so far? Okay, I'm going to switch to number 2, okay? To have more examples. Number 2. Number 2 is 0.000355. First question, what do you notice about your value? Is it greater than 1 or smaller than 1? Smaller than 1. So you will expect your exponent to be negative. That's the automatic thing. You should never forget the negative. Okay. Next, let's identify first our significant figures. How many significant figures do we have in this number? Do we count the zeros to the left? Do we count the zeros to the left? Are the zeros to the left counted? No. So that means how many do we have here? 1, 2, and 3. So let's encircle that. 3 SF. So that means I will just be writing this 3 here in the final answer. Next, after encircling the significant digits, it's time for us to move our decimal point. Our decimal point is here, right? It's there. Where do we transfer our decimal point again? What's the rule? We leave only one non-zero number before the decimal point. So the decimal point has to be transferred in between 3 and 5. After 3, before 5. We only leave the number 3 before the decimal point because that's the rule. Once we know now the final destination of our dot, then we can count how many times we skip. Let's count. 1, 2, 3, and then 4. So you have 4 movements. So you're going to write it down. 4 movements. Should it be negative or positive? Negative, because it's a small number. So I put a negative there. That's very important. Now I'm done with the exponent. That means we're ready to write our scientific notation. Let's write it down. The value of my n is inside the circle. So all I need to do is write it. So that's going to be 3.55. 3 significant figures. Then write down times 10 right away. Times 10. That's fixed. And what will be the exponent? Negative 4. Whatever you wrote there. And that's going to be the final answer to number 2. Times 10 is fixed for scientific notation. That is the format. It doesn't change. Let me snapshot this, and I will let you compare this side by side with this one. Okay, that one and this one here. Okay, that's a side view. I want you to look at the difference between the first one and the second one. The first one was also 3.55. The first one in green, the value is also 3.55. The one in number 2, it's also 3.55. However, the exponent in number 1 is positive 4. The number 2 is negative 4. They only differ with that negative exponent. So what am I trying to say? I'm telling you the importance of not forgetting putting a negative if your value is less than 1. Because that will distinguish a small number from a big number. So the importance of your negative sign if the value is less than 1. That is very important in scientific notation. That's the only way you will know if you're dealing with big or small values. Do you understand so far? Questions? Let's go to number 3. Are you copying the answers in your notebook? Yes? Okay. Number 3. Number 3 is 101,000. What do you notice with the value? Small or big? Bigger than 1. It is bigger than 1. So positive exponent right away. First, how many significant figures do we have in this value? How many? 3. It's the 1, 0, and 1. 0 in between is counted because it's being surrounded by 2 non-zero digits. So that means the 0 in between is counted. So 3 significant figures, let's encircle it. So 101. So now it is 3 significant figures. After we identify that, now we are ready to express it in scientific notation. But before we do that, we need to be transferring our decimal point. Where is our decimal point if the number is a whole number? To the very end. So that means it's here. And where will we transfer our decimal point? In front, or is it after the first one? Or before the 1? Before? It should be leave one non-zero number before the decimal point.
Before the 0.
So before, okay, our basis now is the 1. Should it be before this one or after the 1? This one. It should be after the 1.
Wait, this one can be after the 0.
Because you only leave one non-zero number, always. One non-zero number before the decimal point. So it should be here. There's no other place. And now let's count. How many times we skip? Let's count. 1, 2, 3, 4, and 5. So now we move 5 times. Will the 5 be positive or negative? It will be positive because it's a big number. Now, are we ready to write down the scientific notation? Yes? So the final answer will be 1.01 times 10 to the power of positive 5. And that's the final answer to your third number. Last number. Last number. Any questions so far? Clear? Okay. Last number. We have 0.000010 and then 1. How many significant figures do we have? Do we count the left zeros again? No. So we count here. 1, 2, and 3. 0 is in between, so that's counted there. So we encircle. That's what we will write in our scientific notation. Next, we will transfer the decimal point. Our starting point is here, and we're going to transfer it between the 1 and 0. Is this the 1 or the first one? The first one. So in between 1 and 0. Then we count. 1, 2, 3, 4, and that will be 5. So you skip 5 times. Should it be negative or positive? Negative. Now we're ready to write our scientific notation. It's gonna be 1, the one inside the circle, 0.01 times 10 to the negative 5. And that's it for your number 4. Okay. Any questions so far? Okay.